Buildings are no longer the same as in the past. They have become more intelligent, energy-saving, and even healthier for us. Experts have designed what they call smart materials for construction, some of which can fix cracks by themselves. This technological advancement has also facilitated 3D printing, so it is now possible to finish building a house within one day at low cost. How does this technology help us in our daily lives and in the future? This seminar features Engineer Professor Andrew Leung from the Department of Architecture and Civil Engineering of City University of Hong Kong. He will guide us through a brief introduction to intelligent buildings and talk about his plan to use this technology to combat the COVID-19 pandemic.
After retirement, I have two companies. One is Smart Integration in Science Park, the other Social Enterprise Limited, which is a charity company to serve elderly homes and care homes. I'm also the president of the Asian Institute of Intelligent Buildings, as well as the vice chairman of the China Green Building Hong Kong Council. I was rather ambitious in the beginning to give you an overview like this. Start with thermal comfort. That involves a lot of things, particularly the facade of a building. And then smart materials, energy, and easy space, how to get space easily. And then 3D printing construction, smart building for healthy living. And the last one is digital twin for care homes. So I give you an overview like this. This is a picture downloaded from Google. In construction, you start with smart material. Material is very important. I work with my colleagues on smart materials, drones, and 3D printing. Okay, so I'm working alongside the Caritas Institute of Higher Education on AI. Then I got colleagues to work on the Internet of Things. I also have a former student working at the University of Hong Kong on BIM, Llewellyn Tech. So that is the full picture of intelligent green buildings. Nowadays, we have one more element, which is health. Because of the COVID-19, it becomes important to consider health as well. So we start with very simple, smart buildings. You don't need any energy. Just like the invention of Johnson Control that was 100 years ago. You use two different metals. One expands faster than the other. Okay? So whenever you have a temperature change, it turns. It just turns this side or the other side. Now, these are smart facades. Very simple. In the daytime, you have daylight. It covers everything. And the upper left, when they cool down, all the windows open. On the upper right, you have this solar panel. This solar panel is also very easy. When it is hot, it turns to the sun. It just follows the sun because of the temperature will change the hinge. So your panel will turn without using electricity. And the lower one, you have the window close and open depending on the temperature change. The lower right, it's just like a lantern. It just open up your window according to temperature. So when the sun shines on you, it closes automatically. When it is cooler, it opens up. So this is a very energy efficient because you don't need any energy to open your window and open up your facade. Now, this is something from City University, my colleagues, passive radiation cooling. It is actually a bio-inspired polymer surface. You look at the Sahara silver ant. The temperature is so hot in Sahara desert, and the ant gets burned very easily. But ants are very clever. You look at the surface of the skin. It's just like a pyramid, a triangular the surface so that it reflects the heat and light from the sun to the sky. Now, you look at the lower middle picture. If you use different shapes, you compare triangle, rectangular shape, as well as circular shape. You can see the most efficient shape is the triangle on the top. The lower left diagram, you have this picture. On the roof, one part of it with the paint, the other part without the paint. The net cooling power is actually, you have 144 watt per square meter. So you save a lot of energy. And the cooler always remain at 6.2 degrees, lower than the ambient. That belongs to the material. Even the ant skin is some kind of material. And this one, it gives you an overview of smart materials. So in order not to use any additional energy, we look at the temperature change. Things become smart. Mechanical strain means you step on it, you change a lot of things. Electrical field, you change a lot of things. Electric current also change a lot of things. So we have this shape memory alloy. Shape memory alloy is for your artery operation. The doctor insert a net into your blood vein. When your body gets warmer, it expands. It expands to the original shape so that when it goes in, it is just like a needle. When it goes in your vein, it expands. Okay, that's what we call the shape memory alloy. The second one, due to temperature change, is pyroelectric. So when it heats up, you have this electric polarization. It means the positive and negative going apart, further away. Then you have this hysteresis cycle generating energy. And mechanical strain, so you have electrostrictive material, electrostrictive material. When you give strain, it changes the magnetic field as well as electric field. And even if you have electric field, it will change color. That is what we call the electric chromic. Therefore, you don't need a curtain. When you give electricity, your transparent curtain become white. Or you have a smart bathroom, okay? So without electricity, you see through everything. But you go to the room, switch on the light, it becomes non-transparent, so you can have your privacy. So that is what we call electrochromic and piezoelectric. That can exchange electricity with mechanical strain, or vice versa, the other way around as well. That is another overview of smart material used in a building structure. So we have smart structures like self-healing material. I will talk a little bit later on. And we have a smart construction material as well as non-construction material. Non-construction material is for windows, just like I talk about these smart windows. And also smart base isolation system. This is the overview. So that is a few smart materials, a smart brick. You can implant a smart pallet inside your brick. In fact, in Hong Kong, many construction, they put this smart thing inside the precast concrete. You can put this into smart brick or smart concrete. So with that, you know exactly where that piece of material can go. And you can control the brick. Actually, you can have antenna. In fact, the antenna is very simple, like your smart car, your octopus car is already antenna. Now, the top one, this one, is like a smart car. The lower one is a super bamboo. Super bamboo was also invented by my colleagues at City University. I'm sorry, because I'm from City University, so I talk more about City University's smart materials as well as green materials, healthy materials. Okay, now look at the lower right picture. You can see that the natural bamboo in green is about 100 MPa. But if you treat it, you can go up to 350 MPa. So it's 3 or 4 times of the original strength. With that, it is stronger than steel. high-strength steel. The high-strength steel is 250 MPa. Now, just bamboo, you come to 350 MPa. Therefore, we can use lateral material to replace steel already, stronger than, this is a volume ratio, okay? The same volume of treated bamboo is stronger than steel. Another one is self-healing construction material. Nowadays, if you have a crack on your roof, it is very troublesome. It leaks. But for this one, you have a pellet. The pellet inside will have some kind of bacteria and also nutrients. And this bacteria with nutrients will not grow until it gets wet. So when you have a crack, water goes in, and the bacteria will digest this nutrient and produce calcium to fill the gap. So with that, whenever you have cracks, calcium automatically generated to stop the leakage. And then I can talk about energy. There are many very cheap energy, like any energy harvesting, some piezoelectricity. You look at some children, they have shoes. Whenever they walk, you can see light in it. It is what we call a piezoelectric generator. And we can generate vibration energy to light up street lights. That's what I did in the year 2000. Generate electricity from temperature difference, thermoelectric to eliminate cooling tower. Nowadays, you have to use water to cool the tower. But if you use this thermoelectricity, you can generate heat from the cooling tower without using water. So you gain two things. Because the heat of the cooling tower, you can generate electricity, and you don't need any water to cool it. On the right-hand side, it is the Chingma Bridge. I put in the energy harvest. The vibration energy of the whole column is transferred to the top. It vibrates. With the electric coil, it generates electricity and light up the lantern. Okay, that is what I did quite some years ago. And the middle one is what you call piezoelectric. So you step on it, you generate electricity. And in fact, it can be used on the highway, the cat eye, I think, on the highway. Whenever traffic go over it, it generates electricity to tell you the condition of the road. And the top left is a heat pipe. The heat conduction of heat pipe is 100 times faster than aluminum. So if you can have a heat pipe, cold air come in and hot air go out, just like our heat exchange. But with that heat exchange, we can generate electricity as well. So I got a US patent in 2018 to use thermal electricity to get rid of cooling towers and generate power by micro technology. So easy space. When I was at City University, I was involved in this tunnel boring machine to make tunnels. In fact, I recommended to our president to build an underground city between City University, Productivity Center, and the Jockey Club, and so on, because these are all what we call GIC land. We can use the lower part. And I told him that we need $2 billion to make an underground city using the tunnel boring machine. But eventually it didn't happen. And also I have a project, a mega box project, because they have this, what we call the garbage compactor. You have all this garbage, you compact it, make it solid so that it can be easily transported, save a lot of space. But this compactor is very annoying. It induces rats, induces crocodiles, smell bad. So I use a probiotic bacteria to eliminate all the odor, the bad smell. And then they get space. Initially, nobody like to stay there, but now they can have office just by the side of the compactor. Okay, and the same, I did it for Changshawan Plaza. It was a sewage system, but they are using it as a lunch space for staff. 3D printing. Now we talk about 3D printing a lot. It is a hot topic, but mind you, there's a catch. 3D printing can print in the exact direction only. It cannot print the roof, because if you have nothing to support the roof, you cannot print it. So like this ceiling, you cannot print the ceiling because look, you have nothing to support it. But there are tricks, of course, we can do. Just like the bridge, they make the art first and put it backwards and do the top. So there's a lot of technology in it. Even some of the housing in US, they just use $4,000 to print a community house in 24 hours. Now we talk about comfort. In fact, there are many comfort index. So you have the first, the IAQ is the air index, ITQ thermal index, lighting index, just now we talk about lighting. And VQ is view and sound, space, and so on. Now this is my invention. we all talk about COVID-19. Everybody say they can disinfect the air. But I tell you, nothing can do, because even titanium dioxide nano, it works on the surface only. UVC works on the surface only. I did it using plasma. But plasma is very, very small. It's like Armstrong size, very small. So I invented the Kiosa, the middle one, the Kiosa, so that from 20% disinfectant efficacy become 99.9. So I did a lot for clinics and so on. That is another digital twin in care homes, because you have two separate groups of people. One group inside the care home, the other outside. The outside one has to know what is inside. So I did a lot during the time, and there's a lot of IoT being implanted. Okay, I give you the last picture. This one, I'm working on it, because you use a camera to get your blood pressure, okay? So that is what I'm working on. In fact, I initiated this because MTR asked me to use a camera to capture the driver behavior, whether sleeping or not. So, but I prefer this one because I'm working on elderly homes. Using a camera to get the blood pressure, to get the heartbeat, to get the respiration rate, and to get also the SpO2, the oxygen level. That is very good for old people as well as for baby. Thank you very much.